The next concept what we are about to learn here in the concept of sets is complement of a set. Okay, complement of a set. Now, what we mean by complement of a set? Suppose, let's say you have a set A, which is, let's say, 1, 2, 3, 4. And set A is a part of a universal set U, which is 1, 2, 3, so on and so forth till, let's say, 10. We have a universal set which goes from 1 to 10, and set A is 1, 2, 3, 4. Now, what we know and what you can conclude from this particular thing is that A is a subset of U, correct? A is a subset of U. Now, if you write the same thing in Venn diagram, what we have, this is set A. So this is U. So this part is going to become set A, which has 1, 2, 3 and 4. And this is the universal set, correct? Universal set contains everything and set A is a subset of U. Now, complement of A is basically elements which are present in the universal set but not in A. Okay, that means elements which are not present in the particular set but it is present in the universal set. That is what we call as complement of a set. Okay, now the general definition, I would say, the general definition can be written as that X such that X does not belong to A, in the sense A complement. See that A dash also you can call it. A dash is equal to X such that X does not belong to A and X belongs to U minus A. This is basically complement of a set. Now, for this particular question, the example what we are taking, you have U, which is from 1 to 10. A is 1, 2, 3, 4. Correct? The elements which are in the universal set but not in the given set. That is nothing but complement of a set. In other words, here A complement becomes 5, 6, 7, 8, 9 and 10. This is A complement, or you can also call it as A dash. Okay, now this is what we mean by complement, and this is the definition of complement of a set. Fair enough? Now let's look into certain properties of the complement of a set. See, the first property, a very simple property. Suppose if you have A union A complement. See, when you take A, the elements, and the union of things which are not there in that particular set, this is going to give us the universal set. Universal set. Okay, and one more is A intersection A complement is null set. Now we can easily verify this with the help of a Venn diagram. That means, suppose, see here, if this is set A and this is the universal set. Okay, this is A, this is universal set. Right, now the outside part, that means this part, what we are looking at, this part, what you are looking at, this is nothing but A complement, isn't it? Since this is A complement, the union of A and A complement, obviously it's going to give you the universal set. Because look at it, A union A complement is the entire thing, which is the universal. And for the intersection, there is no common thing between A and A complement. Hence, we are going to get a null set or an empty set. Correct? This is the first property of complement of a set. Second property, we are going to deal with double complementation. That is, we do A complement of a complement. This is going to give us A itself. A complement of a complement is A itself. Okay, this is what we call as double complementation. See, the next law, or more than a law, you can call it as a property. When you have a null set, okay, phi is a null set. The complement of a null set is universal set, and complement of a universal set is a null set. Fair enough? So it's the opposite. Phi complement is u complement is phi. Clear? This is another property. Now the fourth property what we are going to discuss is an extremely important property. Okay? The fourth property, we call this as De Morgan's law. Okay, we call this as De Morgan's law. Now, this particular law or property is used in many cases. Okay, not just in sets. We use this in probability, we use this in computer science, we use this in semiconductors, in logic gates. We use this in many fields. De Morgan's law. Basically, the Boolean algebra comes from De Morgan, not comes from De Morgan's law, but De Morgan's law is a part of a Boolean algebra, which you guys are going to study later on. Now, what De Morgan's law states is that suppose if you have A union B whole complement, then this is equal to A complement intersection B complement. Okay, this is one of the De Morgan's law. Second one is if you have A intersection B whole complement, this becomes A complement union B complement. This is the second one. So these two together are what we call as De Morgan's law. Now there are a lot of problems based on this De Morgan's law, like given set A, B and this is the universal set. Show De Morgan's law is true or prove De Morgan's law. Like this, you have a lot of problems based on this. Alright, now understood what is a complement and the four properties. Complement is what? The elements which are not there in the set but it is present in the universal set. That's a complement of a set. Then the properties. A union A complement is U. A intersection A complement is phi. Then you have double complementation. And universal and null set are complement of each other. Then finally De Morgan's law. A union B whole complement is A complement intersection B complement. And A intersection B whole complement is A complement union B complement. Correct? So these are the four properties and one of them is very important, the De Morgan's law. Now in the next video onwards, we'll see certain problems based on this.